Hey everyone, in this video we're going to talk about what might be the most important concept in this course. It's called conservation of energy. Now I say it's possibly the most important concept because everything we do from here on out will involve conservation of energy at some level. In fact, you could say, if you wanted to, that Physics 7a is just a bunch of different applications of conservation of energy. So it's important that we understand really clearly what it means. But let's start somewhere slightly more basic. Before we can understand what conservation of energy is, we need to understand what energy is. Now, you probably have an intuitive sense of what energy means. You need energy, for example, to get up and do things during the day. Your car needs energy to move from one place to another. Your phone needs energy to do phone things. All of these are examples of energy moving from one place to another. For example, in your body, energy is being extracted from the food that you eat and converted into a form that your body can use. In your phone, energy is being taken from the battery of the phone and used to power the various chips, allowing you to scroll TikTok, take pictures, or message your friends. In a car, energy is being removed from the gasoline and put into the movement of the car. Or perhaps you may have an electric car, in which case, just like the phone, the energy is stored in a battery, which is then converted into movement. These are all examples of energy being transformed from one form to another. You can sort of think of energy as like the currency of the universe. In order for anything interesting to happen, you need energy, and specifically, you need energy to move from one place to another, or from one form to another. So now let's think about what energy conservation means. To do that, let's look at a visual example. These two cups both have some amount of water in them. Now, what's going to happen if I just hold these cups here and do nothing? Well, nothing is going to happen. The total amount of water in these cups is not changing. There are actually two ways of saying this. We can both say that the amount of water in each cup individually is not changing, and that the total amount of water in the two cups combined is not changing. Now, you might think these are the same thing, but they're actually not, and I'll show you why. If I take water from one cup and pour it into the other, the amount of water in each cup individually has changed, but the amount of water in the cups combined has not. We haven't lost any water. It's just been moved from one cup to the other. Now, of course, there's nothing that requires me to pour water from one cup to the other. I could just pour some out. I probably should have thought more about that before I did it. In doing so, two things are now happening. Both the amount of water in this cup is changing, and the total amount of water in the two cups combined are changing. Energy works a lot like this. When I poured the water out of the cup, the water didn't disappear. It didn't just evaporate into nothingness. Instead, the water just left our system. We can think of these two cups as our system. They're the thing that we care about. Once the water leaves the cup, we don't really care where it went. We just know it's gone from our system. But crucially, it's not gone. It's somewhere. It's just not in the cups anymore. Energy works similarly. Whenever something interesting is happening, energy is being moved from one form to another. As our example from previously, if I drop this object, it's not that the amount of energy that the object has is changing. It's just that the energy is being moved from what we call potential energy into kinetic energy as the object falls. We'll talk about potential and kinetic energy more later. In this course, we're going to have two main kinds of systems when it comes to energy. The first we call closed systems. A closed system is like these two cups when I'm only allowed to pour water from one cup to another. In a closed system, the total amount of energy, the total amount of water, isn't changing. It's just being poured from one cup to another. In energy terms, this means it's being converted from one kind of energy into another kind of energy. In an open system, though, this is not the case. In an open system, energy is allowed to enter and leave the system. The total amount of energy, the total amount of water in all the cups combined, is changing. Now, in this course, we generally will not care where the energy is coming from or where it's going to. If energy leaves the system, it's just gone. We don't care about it anymore. By the same token, if energy enters the system, we don't really care where it came from. We just care about how much came in. Now, why is this interesting? Why is conservation of energy interesting? Well, it's interesting for a key reason, and to see that, let's go back to the cups. Suppose I knew exactly how much water was in each of these cups, and I then poured some water into the other cup. If I knew how much water I poured from one cup to the other, I could immediately tell you how much water is now in this cup. It's just however much it started with minus however much I poured out. Same here. It's just however much water this cup had initially plus the amount of water that I poured through. The same thing is true with energy. Because energy can't just appear and disappear, we can determine how much energy has moved from one place to another. The amount of energy in a system is linked very clearly to something else that we can measure about the system. For example, in our cup of water, there is a thing called thermal energy. Thermal energy is just energy that a system has given its temperature. When thermal energy goes up, temperature goes up, and when thermal energy goes down, temperature goes down. Suppose I knew the starting temperature of the cup. I then put some energy into the thermal energy of the cup. If I know how much energy I have added, I can determine how much the temperature changes by. Now, we don't know how to do this yet. We'll start seeing this in the next video. But the key takeaway is that by putting specific limits on how energy behaves, we can determine interesting things about how the world will behave. Let's think about one more example of how this might be useful. Suppose I have a thermos full of coffee. Now, this thermos is not truly a closed system. It can't really keep the coffee warm forever, but for the moment, let's pretend it is. In other words, once we close the lid on this thermos, we're going to pretend that no energy is allowed to go in or come out. Suppose I had this thermos filled with hot coffee and I dropped an ice cube in. Closing the lid means that the total amount of energy inside the thermos is now fixed. It cannot change. And a question that I might be interested in is, what would the temperature of the water in the thermos be after the ice cube melts? Intuitively, we know that it's going to be a little bit cooler, but how much cooler? Knowing energy conservation allows us to do that because we can determine how much energy is transferred from the ice into the water as it melts. It depends on a few things, including how much ice I put in, how much coffee is in the thermos, and the temperature of the ice and the coffee respectively. Now again, we haven't actually seen how to do this yet. The important thing to remember is that we can. We'll see how soon. If you take away 3 things from this lecture, I want them to be these 3. First, energy is conserved. When we have energy, it's never going to just appear out of nowhere or disappear into nothing. It's always going somewhere. It might go a place that we don't know anything about, in which case it's just lost. As long as we know how much energy left, it's fine. Same with energy coming in. As long as we know how much energy came into our system, we don't really care about where it came from. The second thing is the difference between an open and a closed system. In a closed system, like this thermos with the lid closed, the total amount of energy is constant. It cannot change. It can go from one type of energy to another type of energy, but it can't change. In an open system, the amount of energy is allowed to change. That energy is either coming from outside somewhere or leaving to the outside. Again, we don't care necessarily where the energy is going to or coming from. We mostly just care how much energy is entering or leaving. Lastly, knowing these facts about conservation of energy allows us to determine how systems will behave in the future. The example I gave was the ice cube in the thermos of coffee. If I know how much coffee and ice I start with, and I know what their temperatures are, I can tell you exactly what the final temperature of the coffee will be once the ice cube has melted. We'll see how to determine that next time.